A manifestation of climate change is present in almost every region on Earth, from the recent ignition in tropical weather in the past decade to the record all-time low ice pack in the Arctic. While these events alone have a large impact on our economy, our biosphere, and our personal well-being, climate change possesses another threat that is often overlooked. This veiled threat already causes hundreds of millions of dollars to the Mid-Atlantic and New England states. I'm of course referring to nor'easters. Our changing climate may add fuel to the fire that ignites these powerful storms.
On average, Washington, D.C., Philadelphia, and New York City see events with snowfall totals of greater than 10 inches about every 2 to 3 years. The winter of 2009 to 2010, however, residents of the Northeast experienced 4 major storms back-to-back with snowfall totals over 20 inches, an unprecedented season. So how did these memorable storms, like Snowmageddon and Snowicane, come to be? 2 factors that are important to the formation of nor'easters are the El Niño Southern Oscillation, or ENSO, and the North Atlantic Oscillation, or NAO. What is El Niño or La Niña, and how does it affect the winter season? ENSO measures the location of the warmest sea surface temperatures in the tropical Pacific. Typically, the warmest ocean water lies in the western Pacific, but during an El Niño winter, warmer temperatures are distributed to the eastern Pacific. This change in temperature alters the movements in our atmosphere, which ultimately have effect on our weather patterns here in the Northeast and all over the globe. ENSO is usually mentioned in reference to tropical meteorology, but it also has a significant impact on winter weather. In fact, a 2001 study quantified the number of storms that affected the eastern coastline. It was found that an El Niño winter exhibits a 25% increase in storms, which is about 3 additional storms on average. A 2006 study, which focused on the southeastern region of the U.S., found that the number of storms that formed and traversed through the southeast more than doubled during an El Niño event in comparison to a La Niña or neutral winter. The North Atlantic Oscillation is also important to the formation of nor'easters due to the effects on the location of the jet stream, which can supply cold air to the northeast and a storm track along the coast. In NAO's positive phase, the jet stream blows straight across the country in a zonal pattern, for which mild weather is typical. The negative phase of NAO creates a meridional flow and a trough across the eastern half of the U.S. This brings cold air and coastal storms to the northeast.
In March of 1993, an El Niño winter and a negative NAO partnered up to produce one of the most significant winter storms in the history books. Known as the 1993 superstorm, the system dumped over 30 inches of snow in many locations and affected the entire eastern seaboard.
In this reanalysis of the 1993 storm, notice the large trough or dip in the jet stream. As previously mentioned, this was one of the reasons this storm was able to intensify so quickly. This meridional or curvy flow was established because of a strong negative NAO phase. Additionally, this type of flow also creates a large difference in temperature, with cold air being ushered in from the Arctic and warm moist air flowing in from the Atlantic.
Over the past 50 years, there has been a trend towards a positive NAO, which if continued in the future might lead to less nor'easters. Global climate models are not accurate enough at this point in time to model the smaller scale weather patterns that NAO creates. However, multiple papers have stated that various climate models have been used to simulate NAO, and the recent upward trend cannot be achieved without some sort of atmospheric forcing. This leads to the belief that this bias is due to anthropogenic effects.
We've established major contributing factors to nor'easter frequency, but how are these factors going to vary as climate continues to change? In a simple world, ENSO would continue to act much as it always has, simply oscillating between El Niño and La Niña phases as the globe continues to warm. While this would make our study of Earth's future climate much less complicated, it's likely that the magnitude of ENSO's variations and the frequency of these events will change. However, it's unclear how ENSO will evolve. There are many feedback mechanisms in the tropical Pacific Ocean that have an effect on the state of ENSO. These processes will either have an amplifying or dampening effect that can cancel each other out. While some research suggests that ENSO will remain relatively the same in a warmer climate, it is unknown how the surrounding global climate will affect ENSO. Currently, not enough research has been done to have a complete understanding of whether or not we will see more El Niño, La Niña, or neutral winters. Moreover, there are unforeseeable changes that might occur on our planet that could modify climate change, such as volcanic eruptions and solar output variations. So what does climate change mean for winter storms around here? While we're unsure about the changes of NAO and ENSO, we do know that our winters will be warmer and wetter than they currently are. This being said, we can expect that more precipitation will fall as rain rather than snow in the coming decades.
For more information on how climate change affects nor'easters, please visit the following sources and links.